Lesson 5.3.3 Proving Triangle Congruence Theorems, AAS and SSA. Creating a flowchart proof for the angle-angle side theorem. So vocabulary: angle-angle side theorem, or that is definitely not the right letters, or AAS would be the letters for it. And it states if two angles and the non-included side of one triangle are congruent to the corresponding two angles and the non-included, or I should say a non-included side of a second triangle, then the triangles are congruent. So what this means is, here's my first triangle, here's my second triangle. They're saying that this angle is congruent, and if this angle is congruent and one of the sides that's not in the angle is congruent, then the two triangles are congruent. The other thing to note is that if you have this side congruent and this side congruent and an angle that is not included congruent, we cannot necessarily state that the two triangles are congruent. So congruent by AAS not necessarily congruent. Okay, this would be the case of a side and an angle. It's not that they're not congruent, it's that with that they're not necessarily congruent. All right, let's go on to the notes. Determine if the two triangles are necessarily congruent. If so, fill in a flowchart proof to prove that they are. So, taking a look at this, at number one here, we have this angle congruent and this angle congruent. We have this angle congruent and this angle congruent. And there's a mistake in my drawings here. It wouldn't be this side that's congruent, it would be this side congruent. Okay, so the third thing is we have this side and this side congruent. And the reason it was not the one that was between S and T is because S and T is the congruent side angle with M, and on our first one the congruent angle is K and L, so this should be in the same place. Okay, so they are congruent, or they are necessarily congruent, and we can make our statements. Our first one would say that angle K is congruent to angle U. Our second statement would say angle M is congruent to angle S. And our last statement would say side LK is congruent to side TU. It would be okay if side ST and ML were congruent as well. It just has to be one side that's not between the angles. So since those are given and those are congruent, then triangle KML is congruent to triangle UST because of AAS, angle side theorem. So I'd like you to try number 2 right now and then check with the video to see how you did. But before you get started on this, again, we have an issue with how I have the third one marked, or the side marked. The side here should be, or yeah, needs to be this in order for it to work out right. So with the new markings, you should fix it on your paper and then try this one on your own and check and see how you did. Okay, so hopefully you said that they are necessarily congruent, and you found that angle O is congruent to angle Q, and angle M is congruent to angle P, and side LO is congruent to side RQ. And because all those are congruent, we can say that triangle OML is congruent to triangle QPR, with the reasoning that angle side theorem. And with that, that's your first set of notes for today.